two main things we're going over today, everybody. Two main things, and then I'm going to tell you how today's class is going to work. So number one, with all rate word problems, I think it's a pretty good idea or a pretty good feeling when at the very least, you're able to look at a number and know if it represents a distance, if it represents a rate, if it represents a time. Knowing what numbers represent, huge deal. Got to make sure we focus on that first. Now, number two, once we know, how to identify these specific parts of the formula, well, the second thing we need to understand is, well, how do we set up this formula? Because there are going to be times where you're given a problem and you might have more than one rate, more than one time, more than one distance, and you need to know how it fits into the problem. And so we're going to be talking about those two main things. And the third thing that I want to mention before we begin is this. We're going to be going over a few different types of rate word problems today. There might be problems about objects going in the same direction, opposite directions, or catching up or moving away from each other. We're also going to be looking at problems that might have one person in different situations, or someone going along the same route back and forth. We're going to be looking at all these different situations, and I'm not going to tell you that we're dealing with that type of problem. I might hint at it, might give you a clue or two, but after you try it out yourself, that's when I'll go ahead and really introduce that idea, exactly how to do it. And I want to see if you can figure it out intuitively beforehand. That's how today is going to work. Now, remember, today and tomorrow, we're doing the same exact topic, rate word problems. And so tomorrow's class is only for program members. So again, if you're interested in that, just stay to the end of the class. We'll talk about it. I'm going to cut class short about 5 minutes to really introduce you to it if you want to learn more about it. But with that being said, again, today we're going to be going over a few different types of rate word problems. And then tomorrow, we're really going to be separating those topics and looking at the specific notes for each and really diving in. So let's go ahead. Let's get going, my party people. So here we go. Let's go and get ready to take some notes here. As always, my MASVAB party people, thank you for watching this video. Before we continue, just wanted to remind you that if you're struggling with the ASVAB, if you struggle with test anxiety, blanking out on problems, then you need to consider the ASVAB All Access program. Thousands of my students have tried it out, and they have always raised their scores if they use it the right way. Because there's always a way to learn for whatever method you like best. From recorded lessons, to live classes, to guided practice videos, to printable worksheets, to speed drills to help you test and raise your confidence and speed, to casual practice that comes with video solutions. Every single way that you can think of, over 10,000 questions, all of it lined up for you, ready for you to get started right now. So at the very least, check out the link in the description so you can see exactly how it works and why, again, over 1,000 of my students have raised their scores with it all the way through. I'm proud of you. Let's keep working hard and let's get back to the video. But don't forget, check out that program. I think you'll like it. First things first that I need you to do, your formula. Go ahead, right there, distance equals rate times time. That's the first thing that I need you to write down because, well, you can't use the formula if you don't know what it is. So go ahead, distance equals rate times time. Erhazy. Okay, Erhazy. Okay, cool. So I'll make sure to remember that. Erhazy. I'm going to write that down because I'm beating myself up. There we go. Cool. So with that said, again, first things first, got to know the formula, right? Now, when we look at these names, everybody, is it fair to say that when you read the word distance, is it fair to say that you start thinking about things like feet, inches, miles, kilometers, things like that, yards, inches, centimeters? Right? That's pretty fair to say. And so make sure to keep using the chat box here because I want to make sure I get your opinion, all right? Because the communication is really going to help us make the jumps that we want to make. So here's the thing. Distance is not actually distance, okay? Distance is really, I want you to consider it like this. Distance is really the amount that you're trying to accomplish. So if you're talking about a problem where you're talking about, Brian, and Brian's trying to bike 12 miles, yeah, that's the amount he's trying to accomplish. He's trying to accomplish 12 miles of biking. But the thing is, there are other problems that you might not know that you're dealing with a distance. So for example, Has anyone here ever dealt with a problem like one where you're talking about, let's say, a conveyor belt? Let's go ahead and say that you're talking about a conveyor belt problem and it says, hey, this conveyor belt processes 4,000 products every hour. How long will it take the conveyor belt to process 20,000 products? Now, if you're dealing with a problem like that, notice we didn't say anything about inches, feet, miles, yards, centimeters, kilometers, nothing. But that is a rate problem. And so don't worry. Most of the problems today are pure distance, but I want you to understand that what you're trying to accomplish, that is a distance, okay? So if you're trying to see how long it takes to scan 20,000 items, well, the 20,000 items is your distance. You're trying to accomplish scanning 20,000 items. So with that said, has anyone ever done a problem sounding like that, but you didn't recognize that it was a distance rate time problem? But looking back at it now, you're like, wait, that might be one. Okay. And so there's a follow-up question that I know a lot of us might have when it comes to understanding distance in this way now, because you deal with a lot of problems that deal with a lot of different things and items and distances. And so your question might really be, well, coach, doesn't that make every problem a rate word problem? No, absolutely not. And so when I talk about rates, that's going to be the dead giveaway. That's going to be the dead giveaway in terms of that you're dealing with a rate word problem. But again, number one, talk about distance. Let's write this down. 3 ways you can really think about it. Again, the amount you're trying to accomplish. So amounts that could be, hey, weight, items, reading a certain number of pages. So another example, hey, Stacy reads 32 words per minute, and she has an assignment to read 1,500 words. How long will it take Stacy to read the assignment? Has anyone ever heard of that kind of problem? That's a rate word problem. Pages is what you're trying to accomplish, and you have a rate in there, pages per minute, and then you have time. That is absolutely a rate word problem. So another type of rate word problem that you may not know is when you're dealing with money. So dollars and other units or the currencies. Again, as long as the problem is in this kind of form, if they say, hey, let's say that John is trying to save $12,000 for a new bike, and he is saving $300 per month of his paychecks right there. Now that you know how quickly he's saving money, that dollar amount, that $12,000, that becomes a distance. That becomes the amount you're trying to accomplish because you're given a rate to go along with it. So we'll talk more about that again. Like I said, we'll talk much more on that. But then obviously, number 3, straight up distances, looking all the way there at the bottom left. Yeah, miles, yards, feet, kilometers. Yep, pure distances are also distances. So don't worry about that. But again, you might be looking at a word problem that says, hey, we're building up a square fence. Each side is 2 feet. Now you're reading that, you're thinking, well, 2 feet's a distance. But the thing is, if they ask you what's the area of the fence, well, that becomes an area problem, not a rate problem. You don't see a rate in there at all. And so let me point something out very quickly. If you're confused at all, don't worry. Because what we want to do here is, again, take these main notes and then just have a conversation with me. And so one thing that you may not have noticed, especially if you're new to this, is the main way to tell that you're dealing with a rate word problem is you need to identify the rate. If you can identify a rate, then you know you're dealing with a rate word problem. So let's just go ahead, take a second, and understand what the heck a rate is. Before I begin, can anyone give me a synonym or a word that describes rate that means the same thing? What's another way to say rate? Oh, no, I'm not asking you how to identify a rate. I'm asking you, what's another word for rate? Not the key word to identify a rate. That's the word per. We'll talk about that. Someone said it started with an S. Starts with an S. That's right, speed. Rate and speed, same thing. At least for the sake of the ASVAB, okay? At least for the sake of the ASVAB, rate and speed are going to be the same thing for us. So let's go and talk about this real quick. So right over here, rate is the speed or the pace that you're going for that distance, or the speed or the rate or the quickness or the pace that you're accomplishing that distance. And so let me give you a few examples here that you can obviously write down, please do. But we're gonna go ahead and give you a couple of examples so that way, when you see all of these word problems today, you can be absolutely sure that each and every single one of these is a rate word problem. Number one, here's first example, pages per minute. So I think we can imagine that, right? If we're saying, hey, I can read 2 pages per minute, every minute, 2 pages, right? That's a speed. That's how quickly things are going. Let's talk about, let's say something like weight, pounds per month. Hey, I'm trying to go ahead and get in shape for my physical over at MEPS. And it looks like if I'm going to be scheduled to go in December, I need to lose 4 pounds per month. Cool. 4 pounds per month. Over here, let's take a look at the distance here. So number 3, miles per hour. I think a lot of us recognize that. Miles per hour, I'm pretty sure a lot of us recognize that. And another one here, dollars per hour. If anybody here has a job, you might be paid hourly. Dollars per hour, if you didn't know, that is a rate. The rate at which you earn money. The rate at which you're traveling for miles per hour. Pounds per month, the rate at which you're gaining or losing weight. Pages per minute, the rate at which you're reading a book. So everybody, quick question. What's a similarity, or what do these examples all share in common? What do you notice that these all share in common? The word per. Yeah, absolutely. The word per. All of these share the word per. Now, there are others, but this is honestly 97% of the time when you're dealing with a rate word problem, 97% of the time, this is the word that they'll use, per. Okay, 97% of the time. I'm not going to say 100 because they can absolutely switch it up if they want to, but you're going to be able to tell, and I'll show you the way if there comes a problem. But I want you to write that down. The word per identifies the rate. And let me actually put that right over here. So the word per identifies the rate. Okay, the word per identifies the rate. Dominic, another phrase that would identify it would be something like for every. So it could say, for every 2 hours of work, Jacob earns $30. Yeah, no problem. And again, we'll take a look at these examples one at a time, so don't worry. And so time is pretty much how long it takes to achieve that distance. So time is pretty identifiable. I mean, we can only really deal with seconds, minutes, hours, days, weeks, years, pretty much. You're not really going to have a rate word problem that talks about centuries. So basic time measurements, seconds, minutes, hours, days, weeks, years, that's time. That is time. And so let's just recap on this one more time, and then we'll talk about this purple note right there. But let's just recap this one more time, and I'll let you screenshot just in case we didn't have enough time to write things down. So first off, distance. Remember, yes, inches, feet, miles, yards, kilometers, those are all distances. But remember that the true general definition of a distance is the amount of anything that you're trying to accomplish. So it could be the amount of money you're trying to save up for a trip or a product like a bike. It could be the amount of pages or words that you're trying to read. It could be the number of words that you're trying to learn for the ASVAB. All these different things. Any amount, anything you can quantify could technically be a distance. But remember, what we got into right after that was this. Just because you notice a distance in a problem doesn't mean it's a rate word problem. If it's a rate word problem, there must be a rate. And that is identified by the word per. So again, examples that we were talking about were pages per minute. So how quickly you're reading every minute. You could be talking about hey, how much money you make per hour. And let's say we're working in the ideal situation. Let's say you're working at the best McDonald's on earth. You're earning $50 an hour. Shout out anybody out there. But yeah, if you're working at a McDonald's making $50 an hour, $50 per hour. That's how much money you're making over time. Remember that the rate or speed is how fast you're doing it. If you see anything that identifies how quickly something is happening, the pace at which something's happening, how fast you're doing something, that is a rate. The dead giveaway, the word per. No worries, Krista, I got you. And then lastly, time, anything that talks about any time frame, seconds, minutes, hours, days, weeks, years, boom, you're good there. So with that said, we're about to move forward here, but we got to talk about one more thing, that purple little note. But before we do, yes or no, do you have a slightly better understanding of identifying a distance, a rate, or time? Again, like, step one is being able to identify these things. You know, that is the first thing. And now there are going to be two more things that, there's going to be this purple note, and there's going to be one more note that I'm going to write down underneath it to make sure that you are absolutely golden. So, but I think I have that. Yeah, never mind. So I have that up next, so I don't have to worry about that. But also over here in purple, this is something you absolutely want to write down. Make sure the units match up. Make sure the units match up. And I'm going to tell you why this is important. So the reason this is important, making sure the units match up, is this. There have been a lot of situations, there are a lot of problems where, and listen to me very carefully after you're done writing, you could have an example that says, hey, this car travels 60 miles an hour. How far does the car travel in 30 minutes? Now, if you listen carefully, you might have noticed that I said the car was going 60 miles per what? Right, 60 miles per hour. That's what I said. I said that car was traveling 60 miles per hour. But then the question that I asked was, how far will the car go in 30 minutes? Now, if you see that, everybody, hours and minutes both represent what? Hours and minutes both represent, time. They both represent time. But the problem is that if you're going to be putting both of those numbers in there, the 60 miles an hour and the 30 minutes into the same formula, you would get the answer automatically wrong because you have your rate operating in miles per hour, and then the time that you're putting in is minutes. So what happens here is that you're not dealing with the same units. And if you don't deal with the same units, you're going to get it wrong. Just like any other problem where you're saying, hey, I have 2 feet of wire here and I have 7 inches of wire there, add it together. Well, if you add that together, that's not going to be 9 feet or even 9 inches. It needs to be the same unit before you add them, because then you'll have the proper answer. Same thing with rates. Make sure your units of your pieces are of the same kind. Yeah, got to make sure you convert. And we'll talk about how to do that for sure. Because again, I'm just showing you those common mistakes that are very easy to be made. And we're going to go over these problems and really take care of business. So make sure the units match up right there. Make sure the units match up. Now let's go ahead here. Let's take a look at this next page. And after this, we're going to get straight into some practice problems. So get ready to work. So here, be consistent. Again, represent the formulas in the same way. And it's not just about the units, everybody. This is something that I'm always thanked for in terms of, hey, coach, I saw a problem like this in the test that had tried to trick me, but I remembered what to do. So I'm not going to go over this as just a lighthearted little piece. This is important. So pay attention. Number one, here's what I mean about representing the formula in the same way. Here's exactly what I mean. If you're talking about a rate word problem that is asking you, hey, find how long it took Bethany to get to the library. Well, you are not going to set up the formula using Carla's distance or time or rate, or using Stefan's rate or time. If the problem is asking you to find the time it took Bethany to get to the library, when you set up your formula, you need to use the distance Bethany traveled and the rate that Bethany traveled by, the speed that Bethany traveled at. You cannot use Carlos's or Carla's or Stefan's information unless it's connected. Yes or no, does that make sense? If you're looking for Bethany's time, you'll need to use Bethany's distance and Bethany's rate. Another huge one that so many people miss at first, but again, once you practice enough, you'll know what to look for. And now beyond that, one last thing here. If you're looking for, so again, represent the formula the same way. If the question asks you, and I'm going to hint at this now because I do have a problem like this in today's class, if we're talking about finding the time that the entire trip took, well, then you need to use the distance for the entire trip and the rate throughout the entire trip. Or if you're looking for the rate for the whole trip, you need the distance for the whole trip and the time for the whole trip. It is always stated in the question sentence, and that's how you know what pieces of information you need to use. Yes, if you're just trying to pass, you're going to see some very fundamental questions that won't try to trick you in this way. But if you're trying to get anything above a 40, you need to know what to look for here. You need to and must know what to look for. So let me zoom out a little bit, give you a chance to screenshot this, because we're going to get straight into work. And like I said, today's class, we are going to be going over a few different types of rate word problems. I'm going to throw you to the wolves and let's see what's up and see what you got. Because in tomorrow's class, we're going to alleviate that headache. We're going to undo everything. And we're going to look at each of those different types of rate word problems and the tips that go along with them. But today, I'm going to purposefully stress you out a little bit just to show you the different types that you can see on the test. So when you're ready to move forward here, go ahead and just type ready in the chat box. Perfect. Sounds good, sounds good. And let me double check here. Cool. All right, good. Sounds good, sounds good. So here we go. Before we begin, everybody, what's the first step to dealing with word problems that I say? If you're not sure, if you've never been to my classes before, no worries. But what is the first thing I say about dealing with word problems? Read the question. RTQ, if you don't know what that means, it means read the question first. Read the question sentence, not starting from the very beginning, but reading the sentence that has the question. And the reason that that's important is because you want to know the rules of the game before you play. If you know what the objective is, then it's going to be a lot easier to understand what the steps are to get there. So here we go. Question number one. And before we continue, my math party people, really quick before we continue, I know that you're enjoying this video and I want to make sure that more people can enjoy these videos just like you. So if you wouldn't mind, just take a quick second, like this video, comment on it, just showing some appreciation, showing what you learned, and then make sure you're subscribed to the channel so that way when we come out with new videos, typically every day, you can be right there on the spot to catch on to them. So help us help others ace the ASVAB. I'm Anderson. Let's keep going here. A car travels at an average speed of 40. Again, you don't need to do all that. This is 2 sentences, so honestly, either way, you're cool. But the proper way to give yourself the best opportunity to have a clear mind is just starting right here. How far did the car travel? That's the first thing you want to look at, okay? So let's highlight that. How far did the car travel? First thing you want to take care of here. So with that, here's what we're going to do. Oh, and as a reminder, if you are using your phone, make sure that if you have your phone like this, turn it to the side. Go ahead and turn it into portrait mode or landscape mode, excuse me. It's going to give you a lot more room to see what I'm writing, okay? If you're having a little bit of a hard time seeing what I'm writing, again, turn your phone to the side and you should be good. So let's take a look here. How far did the car travel? Everybody, I'm telling you right now, this is a rate word problem. What are we looking for? Distance, rate, or time? Okay, and I see a lot of us are saying distance. That's good. That is correct. Now give me a reason. Why distance? How do you know it's distance? Give me a 1 or 2 or 3 reasons that you know that we're looking for distance here. Okay, great. So I see the first kind of group of people here saying, how far, right? How far does point out, again, point A to point B, what's the distance between? How far is it? Absolutely. Another one is, the car traveled. How far did it travel? That's just a supportive indicator, just supports it. But where's another place that you can look to really know that the answer you're looking for represents distance? Where else can you look? Brian, my man. Yeah, the answers. Smalls, that's right. Yeah, the answers. Everybody, look at the answers. Miles, 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 miles. Remember, when we identify distance, we're identifying, the thing that we're trying to accomplish. And miles, flat out, just a distance. Yeah, that's a distance. Now, if you were to see hours, that'd be time. If you were to see miles per hour, that would be a rate. So if you look at your answer choices, everybody, yes or no, is it clear to see? And are you confident in terms of knowing that we're looking for distance here? Again, the question sentence says how far, and the answer choices even say miles. So is it clear here that we're looking for distance? Looking for distance, right? Great. So let's go ahead and collect our information. Because remember, the first step in every word problem is read the question. Step number 2 is going to be collecting your information. Again, what do you want? What do you have? And then we'll talk about the connection, the formula. But what you have, again, your information, this is where you're going to basically point out all the information that is related to what you're looking for. And how do we know what we're looking for? We already said it. We found distance. So we're looking for the distance that the car traveled. So we're looking for the distance for the car. So any information that has to do with the car and its distance, we want to write down. Watch this. A car, I'm going to let this person in there. But here, a car travels at an average speed. Oh, right there. Car travels, average what? Speed. Everybody, what did I say? Speed is another term for again? What did I say? Yeah, we'll be over 2 objects today. Absolutely. Yeah, that's a rate. A speed is a rate. So that's a giveaway right here. Let me just go highlight that right there. Speed and rate, again, those are the same ideas, especially when it comes to just the ASVAB arithmetic reasoning. And then it says rate of 42 miles per hour. Again, everybody, just pop quiz time. As we get used to this, besides the word speed, what's another key word or phrase that identifies this as a rate? Yes, the word per. Like we said, the word per, let me just give you a deeper explanation here. The word per connects the 2 things. It connects your distance and it connects your time. Just take a look here. Miles per hour. Miles is a distance, time, or hour is time. So you have distance per time. That is a rate. How quickly over time you're accomplishing the distance. Distance per time, miles per hour. The word per connects 2 units together to make it a rate. How quickly you're doing something over time. There's one other number here. 5. What does that 5 represent, everybody? What does that 5 represent? Yep, that's the time. Absolutely. Absolutely. So again, 42 miles per hour represents the rate right there. And then over here in green, 5 hours, that is time. So before I continue, Yes or no? Does it make absolutely clear sense that we are looking for the distance because of the key words and phrases, how far, and then the answer choice is literally saying miles. Number two, do you know that 42 miles per hour is a rate because it says a speed of 42, so that's a rate, or also miles per hour, the word per giving away the rate. And then in 5 hours, it's time. Yes or no, are all three of those elements there for you? We're looking for distance. We see that they give us a rate. We see that they give us a time. Okay, and again, if you're not quite sure how to solve this, don't worry. I'm here to help you. But the first thing we need to be able to do is identify the elements of the formula. Because like I said, because we see that there's a rate given to us, that's how we know that this is a rate word problem. We can have a distance in there. They could literally say, hey, Gary traveled 10 miles to the library and 12 miles to his house. How far did he travel in total? That's not a rate problem. There is no rate there. It just says he went this far over here, this far over there, and that's it. Here, we can tell this is a distance equals rate times time because we have a rate. And so everybody type in that formula for me in the chat box. What is the formula that we are going to exercise here? Hey, I'm glad you're calling it easy work now. I'm glad to make you cry later. So what is the formula that we're going to use? That's right. Distance equals rate times time. Again, I'm going to be very, I'm going to be very repetitive. I'm going to take it nice and slow here in the beginning, because once we start ramping it up and throwing in these different ideas and different situations, those same people that were saying light work might be right back to square one. Don't worry, Dominic, I'm happy to do so. So here we go. Distance equals rate times time, okay? Distance equals rate times time. So do we know what the distance is, everybody? Let me just test you guys one more time. Do we know what the distance is? Do we know what it is? No, not yet, right? So what should we put in place of distance? If it's all right with you, let's just go ahead and put a capital D. Just a capital D for distance, or a lowercase d, it doesn't really matter. There you go. Do we know what our rate is, everybody? Right, 42 miles an hour. 42 miles an hour, so let's go ahead and put that as it belongs. Sounds great. And then lastly, let's take a look at the time. That is 5 hours. We know what that is. It's given to us right there. So we're good. We're going to put in 5. Now, the last thing I want to make sure you always double check on is this. Notice how the rate says miles per hour. So what that tells me, and this is just a pro tip, a test taking tip for rate problems. If your rate is in miles per hour, what that guarantees is that, or what that tells you, is that your distance needs to be in miles and your time needs to be hours. Right over here in purple, miles per hour. The miles represents your distance. So your distance needs to be in miles, which if you look at your answers, yep, it is. And then miles per hour, that tells you that your time needs to be hours. And since it is in hours, can we safely say that the units match up? Can we safely say that the units match up? Yeah, we can absolutely safely tell. I could have given you this problem and put 30 minutes. Could have given you this problem and put something in yards or feet, but not being that mean yet, right? Not going to be that mean yet. So here, D equals 42 times 5. Let's go ahead and get that done then. We see that all we got to do is figure out what 42 times 5 is. So we'll go ahead and work on that right here on the side. 42 times 5 sounds great. 2 times 5, that's going to be 10. Carry the 1. Then we have 4 times 5, which is 20. Then carry that 1. It is 21. So we have 210 right there. D equals 210 what? 210 what? That's correct, 210 miles. 210 miles. And that would be the correct answer. So for some of us, that might have been pretty simple. For some of us, that must have been a nice refresher. So where do you believe you feel so far with this one? Was this more of a refresher for you? Or was this super duper easy for you? Okay, and I wouldn't doubt that the majority of us might feel like it's easy. Wouldn't doubt it at all. Because the thing is, if you've been practicing for a while at this point and you've done rate word problems, this must be recognizable at the very, very least. So good. I'm glad. And if it's a refresher, again, I'm hoping that we're able to understand the components behind things, how to know something is a distance, how to know it's a rate, how to know it's a time. So let's take a look at a problem where, again, distance is not literally a distance. It's not literally a yard, feet, miles, inches, kilometers. Let's take a look at an example that right here, the distance might be something else, just an amount that you're trying to accomplish. So here we go. First things first, let's take a look at the question. So again, if you're confused at any point, know the three-step strategy. You're starting with the question, you work your way to the information, and step 3, then you build your connection. If you've seen my 3 steps to word problem success video on YouTube, again, it's one of the more popular videos out there. The 3 steps that I go through are, hey, what do I want? What do I have? And what's the connection? If you go through those 3 steps, you pretty much guarantee that even if you get confused, you can identify the spot that you got confused at. Was it knowing what the question's asking for? Was it translating my information, like actually knowing what the information means? Or was it setting up a formula or setting up the solution? Which one was it? So with that, everybody right over here, I love that you're thinking ahead, Max. And so let's take a look here. It says, how many laps per minute can Adam run? Everybody, if you had to guess in terms of what we're looking for, would you say that we're looking for a distance, a rate, or a time here? Okay, I see a lot of people here saying rate. Again, I don't like you giving answers without giving me a reason why. Help the person next to you. How can we guarantee that we know that this is a rate? Right, the word per. The word per. The word per gives it away. Right here, laps per minute. Laps per minute, right here. The word per really gives it away. So we are looking for a rate, and we can write that down nice and easy here. Looking for a rate, and we see that it's going to be, again, the word per. And it says blank laps per minute. Now, question, everybody. Question. Just looking off of this, just basing it off of this, laps per minute. What's the unit going to be for the distance in this problem? Who knows? What's the unit going to be for just the distance? The unit, not the number. What's the unit for the distance in this problem? Remember, the distance is what you're trying to accomplish. Are we trying to accomplish laps, or are we trying to accomplish minutes? Right. This right here tells you that you're trying to accomplish your distance over time. Laps is the distance. Minute is the time. Yep, that's right. Erhazy. Got it. So yeah, laps per minute. And again, we're going to support this in a moment. Let me support this for you. I got you. So with that, let's take a look again. We're looking for the rate because we saw the word per, laps per minute. If you've memorized that, good job. Now it's our job to go through the information and understand, well, what does that 24 mean? What does that 6 mean? What are we talking about here? So if we go through, Adam runs, so right here, Adam runs 24 laps around the basketball court every 6 minutes. So right here, 24 laps That's the amount that Adam can accomplish. And right here, the 6 minutes, this is the time in which Adam accomplishes those 24 laps. And that's how we can tell. Again, this is your distance per time, laps per minute. The laps is going to be the distance, and you see 24 laps right there. That's the distance. That's what you're accomplishing. And then the 6 minutes, that is the time in which you're accomplishing the 24 laps. Everybody, yes or no? Does that make sense to you so far? That we can say that even though 24 isn't miles or feet, it's still a distance because you're trying to accomplish 24 laps. So that's what I was talking about earlier. That's what we got to look out for. All right, so let's go ahead and try this out real quick. Let's try a little activity here. I'm going to give you about just 30 seconds, 45 seconds here. Go ahead and set up a formula. How can we set up a formula? I want you to put a variable for what we don't know. That rate, the blank laps per minute, I'm going to put a variable. I'm going to put R. Go ahead and set up our formula for us real quick with what we know, leaving what we don't know as a variable. Okay, go ahead. I'm going to give you a few moments. I'm not going to show the timer on the screen. I'll put that for the practice problems, but give it a shot. Just try to set it up, and we'll see if we can make it make sense. So far, I'm liking these answers so far. Right on. Okay. Sounds good to me. I like it. So as a reminder, everybody, that formula is going to be distance equals rate times time. The distance that we're accomplishing, 24 laps. Do we have a rate? Not quite yet. We are looking for the rate. And then we are multiplying the rate times the 6 minutes. And we know that we're good because, again, the distance is represented by laps. The time is per minute. And since we have laps and minutes, 24 laps in 6 minutes, the setup is fine. We don't have to take care of any unit conversions or anything like that. So let's go ahead and solve. Let's be real, MASVAT party people. You're enjoying this YouTube video, but why don't you join me for a free class? I host a free class once a week for 2 hours. So imagine 2 hours of free ASVAB math instruction by yours truly. We get to ask questions, grow with me, raise your score, and get the job you want. So go ahead, click the link here or in the description to sign up for free. And from there, I'll see you in the next class. But until then, let's get back to the math party. If we're trying to solve this, let's zoom in real quick. If we're trying to solve this, remember the idea here, this is an equation. A very fundamental one, a very straightforward one, but let's refresh just in case we forgot. If you forgot how to solve equations, remember that solving equations is all about getting the variable by itself. Right now, I see that I got the R, what I'm looking for, that rate, is currently being multiplied by a 6, and I want to get rid of that multiplication of 6. Remember that solving equations is all about working backwards. So everybody, what's the opposite or the backward step of multiplying by 6? Who can give me a good answer here? Yeah, sure, I like the word divide, but that's not very specific. Divide by 6, that's not very specific. Appreciate you, Sean. Yeah, then Lewis, thank you. Divide by 6 on both sides. I love how the moment you got that I was being annoying on that, you stepped up. Again, we want to be specific about what needs to be done, because if you're specific in practice, you don't question yourself on the test. You got to do the same thing to both sides of the equations. Remember that. So here, what we'll do is we'll divide both sides by 6. Because again, equations, you got to keep that balance. Got to keep that balance. So here, if you multiply by 6 and divide by 6, cancels out, right? Cancels out. And that was the point. We want to get that variable by itself. And so here, R equals 24 divided by 6. That is the hardest question of the day. I hope not. But 24 divided by 6 is 4. That's right. Boom. It's just going to be 4. Let me actually just move that over here. It's just going to be 4. For what, everybody? For what? Yeah, the 4 is the rate, and the rate needs to include that word per, right? Not 4 laps. 4 laps per minute. 4 laps per minute. Because again, if you ran 24 laps in 6 minutes, that means that every minute you're running 4 laps. 4 laps every minute, 4 laps per minute, same thing. Yes or no, does that make sense? We found the rate. The rate was in laps per minute. Again, you notice what I'm doing here, especially for those of you that are here for the first time. I'm not simply going through, hey, here's step 1, 2, 3, 4. All right, move on to the next problem. I'm trying to do my best to make sure that you understand the reasons why we make these decisions, the reasons why this is set up a certain way. For those of you that are here for the first time, are you seeing what I'm doing here? Diop, yeah. So rate is distance divided by time. So you could see it that way. That absolutely is true. Okay, sounds good. Again, just want to make sure for those of you that are here for the first time, you understand my teaching methodology, because even if you feel like something's easy, I want you to really make sure that you understand the reasons why, so that way you still get something out of it and you still learn. But there it is. The answer here is 4 laps per minute, and that will be A, 4. And before you go, if you like what you saw and you want to raise your score with thousands of practice problems just like that, so you can lower that test anxiety, raise that confidence, go to this link right here to check out the full program. There's a video that shows you exactly how it works, but you're going to get lessons, guided practice, worksheets, speed drills, and everything that you need to feel supported from day 1 all the way until you pass. Again, I'm Coach Anderson, and I'll see you soon.